writing, you can also give me that same reaction so I know that you can see my screen too. Okay, so per your reactions, I assume that my screen can be seen and I can be heard as well. Um, Good evening once again, and welcome to DCIT 104 with Freeman. And today we are going to have a very interactive class. We are going to have to combine our theory, that is the slides aspect, to the actual coding environment. So I will really plead with all of you before others may join that kindly make your coding environment ready behind the scenes as we are going to use it most of the section today. All right, so let's begin. Today we are going to talk about something very important in coding, and specifically C++. Okay, we are going to focus on C++ in this semester. So what are we going to talk about today? Today is section 3. So far so good. We have looked at session 1, session 2, and today is session 3. And I'm hoping that if we don't meet any problems along the way, we will be able to finish with the section as intended to. Alright, today we're going to talk about constants and variables. And for this topic, there are so many ways I can go about teaching it. But I think for me, practically, I think the best way to teach this is actually going on the grounds and then teaching you everything alongside the slide though. But I'll go on the coding environment and then teach you. All right, we are going to follow some rules. There are some rules to follow here. All right, so we are going to look at all that so that at the end of the day we don't just read and learn something, but we can actually do something that we learn. Okay, so that's where it has gotten. So I kind of like foretold you that when we get to this point of our lectures, I will not wait for anybody on the basis of the fact that your coding environment is not ready. I actually pleaded here, and most of you can testify that I pleaded that you should reach out, all right, and if not to me, others, all right, those are they can help you. So if at this point your coding environment is not ready, you kind of like have yourself to blame. Okay, so let's really go. Okay, so today we're going to talk about variables and constant. Now, in our own sense, in our own word usage of words and an understanding, when we say something is a variable and on something is a constant, who can help us and give a practical explanation to that? Not even related to DCIT 104 coding or whatever. When we say something is a variable and something is a constant, in your own words, who can, or your own understanding, who can help us? All right. Let me allow your mics. Okay, your mic is already allowed. I think so. So you can unmute and speak. Yeah. The name is a bit dicey for me to pronounce. So please.
Okay. What I understand about constant is something that no, variable is something that can change in sometimes, but the constant is something that cannot change.
Thank you very much for your contribution. It's very correct, and I really do appreciate your contribution. Any other submission? Okay, then let's proceed. So we will go with what our mate just said, that a variable is something that assumes the position of being able to change its state. All right, so in other basic understanding, let me just bring it down like I always try to do. All right, let's take water for instance. I'm trying to say that water is a variable. Why is that? water can exist in all the three stages of matter. All right, and we all do agree with that, unless you didn't actually do science on the in the SS or basic level. But if you did, all right, you agree to the fact that water assumes all the three stages of matter. All right, so I can't fervently call water. Somebody can arguably say, all right, that water is solid. Somebody can say that, but because maybe in his or her life, he or she has known water to be solid throughout. All right, somebody too can say that water is in a gaseous state. All right, and then somebody can also say that water is in a liquid state. We can't actually give a state to water, but what has been universally let me say recognized is that water is liquid. Okay, but what if my whole life I know water to be solid? Okay, because it is frozen where I am throughout. Okay, and when it changes its state, all right, it assumes a new name. Why does it assume a new name? It assumes a new name so that we can be able to identify this same thing, all right, not as one thing, even though we all know that it's that same thing, but in its different state, it assumes a different name so that it will be easy for us to identify it. Okay, imagine you come and meet frozen water and I tell you that it is water. You see, it becomes somehow a bit of a problem. Somebody say, no, this is not water. I know this to be water. You understand? So when it is in its solid state, all right, we call it ice. All right, and then when it is in its gaseous state, I know it's vapor. Okay, and then when it happens to be in its liquid stage, then we refer to it as what, as the normal water. Okay, that we have. So if that happens, all right, that same entity has assumed different names based on what or its natural look. Okay, so that's what a variable can be. A variable is anything that assumes not only a different value but can also assume a different name. That is what you can change variable. In other words, variables vary. That's what the name actually means. It's something that it has the ability to vary. Okay, and I you really appreciate it more when we are coding with it. And then when we talk about a constant, all right, a constant is something that remains the same as its name states. Okay, it remains the same, and it does not change. It will not change unless you change whatever value you have given to it yourself. Okay, but unless that happens, all right, whatever initial value you have given to that will not change. Okay, so we take two boxes. Okay, we take two boxes. Let's take and then what we do with these boxes is that we name one variable and we name one a constant, or these are empty boxes. Okay, and then we are trying to keep something inside the boxes, and then I put into your hand a 100 cedi note, okay, and a 200 cedi note. Please, I hope we are all following with this kind of logic I'm trying to create. I have two boxes, okay, empty boxes, and then I put in your hand a 100 cedi note and then a 200 cedi note. These boxes have been named variable and constant, okay, respectively. And then I tell you, one of these boxes, okay, when you put something in it, its value will not change. Okay, its value will not change. Whatever you put in it, if you go and come back in the 10,000 years time, you still come and meet the same. And I tell you that the other box too, named um variable, whatever you put in it, bear in mind I said will change, but I didn't say will increase. Please, I said may change. Okay, will change, let me put it that way, but I didn't say will increase. So whatever you put inside that box will change. Okay, when you go and come, probably in the next second, in the next minute to come, the next hour or whatever, month or year or whatever, or days, is going to change. You are not definitely going to come and meet the same thing. All right, and even if you come and meet the same thing at a certain time when you were gone, it changed. But fortunately, you just came back to me the same. That does not mean that it was constant. Okay, it changed. So that box is called a variable box. And you have these two um CD notes in your hand. All right, that's the 100 cedi and then the 200 cedi note. And then I put this challenge to you: which one of these currencies will you drop in a constant box, and which one will you drop in a variable box, and why? Interactive. Let's make the class interactive, please. It will really help us because this, trust me, this particular section is nothing to be really excited about. I'm just trying to make it as fun as I can. So please, let's all contribute. All right. If my question was heard loud and clear, I would like somebody to contribute to why you keep maybe 100 cedi inside a constant box and then maybe 200 cedi in the variable box, or for you as a human being. All right. And then why somebody will say, okay, I'll put the 200 cedi rather in the variable box and I'll put the 100 cedi in the constant box. I want to know. Okay, my friend, my best friend. Yeah, Phyllis, please give me your contribution.
Okay, I'll put the 200 series inside the constant box and the 100 series inside the variable box
Why?
because
Why?
my
Okay.
reason is that the constant
Mhm.
it remains the same. So putting the 200, maybe if I go and come, I will meet the 200. But
Okay.
putting the 100 series in a variable, maybe if I come, I will not see it again or it will change.
What should I be saying? To kind of need
Mm,
to
mm.
do what should I, but there's a tendency that it might increase as well. What about that?
Increase. You made
Yeah,
mention not increase or something like that. A variable, maybe it will change.
I said don't hold it against me that okay,
Uh,
because I said it will change, then the only logic I'm giving to you that it will increase. But I'm saying that it will change, so it can decrease or increase. All right.
okay.
So what will you what will you do? All right, with your money, with your 300 cedi, what will you do with it when these two boxes are given to you? Do you still stick with your answer?
Yeah, I'll put the 200 series inside the constant because I know if I go and come, I will meet it again.
Okay, okay.
That's my,
That's very good. Okay, I don't know how many people will agree with you though. So who else? Who else? Okay, we also have Prince Dako. Prince, please unmute and speak.
Yeah, me, I'll keep the 200 CD in the variable box.
Okay,
There's a chance that it might go up, even though I might lose it a bit. I might gain it as well, so I might gain
interesting.
more. Exactly. So then I
Interesting.
hold the 100 in the constant.
Okay, okay. So I've gotten one vote for constant having a high amount and one vote for variable also having a high amount. Okay, let's try and make this thing odd instead of even. Anybody else? A third contribution. Okay then, let's proceed. So per what has been said here, let's try and then put some logic out of it. You realize that at every 2 points of this the problem is not the boxes. Let me be frank. And when I'm done, you understand and you agree with me, right? For now, I know you don't. The problem is not the boxes, nor what the boxes do. The problem is what you decide to put in the boxes and what it means to you. So that is what we are going to do today. Okay. And if you know and understand the storage space known as the box for now, okay, the storage space you have created and what is capable of doing with what you have, okay, then you will decide that what I have, what does it mean to me, and how am I willing to let it go? And if I'm storing it somewhere, how do I want to come back and either meet it or come back and not meet it at all? So the whole decision is based on you as the individual and how valuable what you have in your hand is to you. All right, and it also boils down to how well you are willing to risk it. Are you okay? Because as for the boxes, they remain the same. They won't change whether you put your 100 cedi there or 200 cedi there. When the box is a constant, it's a constant. All right. And then when the box is a variable, it's a variable. The storage space, okay. But what you want to achieve at the end of the day will determine what decision you make with that money with respect to the boxes. Please, do we all agree? So we can see the variation in their answers because, oh no, he's a risk taker. And somebody is also not that much of a risk taker, even though he will let some amount go. The tendency that he might let some amount go, but he's not willing to let it be a very huge amount. Okay, somebody will be like, okay, after all, there's no harm in trying. All right, let me just lose. So you can all understand the fact that it's about how valuable, all right, the commodity the individual has is to him or her, all right, but not the boxes. All right, for the boxes, behavior will remain as it will behave, no matter what decision you decide to take. Do you understand? So that's what I want you to understand before we get there. When we are creating a variable and we are creating a constant, a container, all right, it's not about the container. There is nothing wrong with the container you have created. But what you decide to assign to the container and how you assign it is what brought about the rules. Because the behavior of the container you are going to create, the storage space you are going to create, is there. But what you will decide to put in there and what it means to you, all right, is what brought about the whole rules we are going to learn about today. Do we understand? I'm trying to bring this thing down, very, very down for us to really enjoy it, okay? Because if I just say I'm going by the slides straightforward, you will not like the lesson. I'm being frank with you. If you like, let's try it for just 30 minutes and see. Okay. So, but I hope you guys are really understanding. Okay, Prince.
Mistakes. Yes.
Okay, okay. All right. So then let's quickly just read the slides. All right. I'm not saying we are going to go straight through, but let's just read it. Okay. We are not just going to ignore it totally. Yeah. So we are going to use it. Right. That's where we are going to fish our knowledge from. Okay. So let's read it. Now let's look at the objectives as we always do. Okay. So we should be able to distinguish among a variable, a named constant, and then a literal constant. Okay. Now, at the end of the day, too, we should be able to explain how data is stored in a memory. Okay. Yes, you went about putting a particular currency. I won't specify the 100 cedi or the 200 cedi, but I went to about putting the currency inside that constant or variable. All right. But how did you do it? Okay, it's very, very important. It's very the how you did it is very, very important. Okay, so that one we shouldn't ignore it. As I stated earlier, what the money means to you, okay, and how you put the money inside the container, all right, and what you're expecting to see at the end of the day, all right, all depends on you. Okay, so that's what brought about the rules. So let's not forget that. Now we also have to select an appropriate name, data type. Okay, we're going to learn how to select an appropriate name, a data type, and an initial value for a memory location. Okay, as I stated earlier, when I created the boxes, I didn't see that there was something in the box, and I also gave the boxes a name. All right, and I stated the fact that you are going to have the opportunity to put two different things. I never said they are all the same thing. I said 100 cedi and 200 cedi. They are all two different things. Okay, so I also told you that you are going to assign to these containers or these boxes some two different things. All right, so we are going to look at it. We are going to really understand it later on. All right, so we are going to look at the name of the container. All right, what can be placed in a container. Are you okay? What can be placed in the container, and whether you will choose to put all the two in that container, one for each container, or all the two currency into just one container. Are you okay? Are you okay? Please give me a moment. Okay. Um, give me a moment. I'll be back. Okay. Let's continue. All right. Sorry for the slight commercial break. Okay, so let's continue. Today we are going to have a look at all these things. All right, and we are going to look at the last part. The last part is what really makes me happy. Okay, we are going to declare a memory location in C++. So please and please, if you know your environment is not set up, be working behind the scenes now, like now. All right, don't let us get to this objective and then say I was not able to follow because of this. I was like, it really won't help us. Okay, so please make him. I assume that by now everybody has the environment ready. Okay, so let's continue. So the last time we looked at beginning step 4. All right, we are beginning step 4 in the process of solving a problem. Okay, the last time we looked at some various steps involved in solving problems as a programmer. All right, and we looked at um, algorithms and desk checking. I think that one was our last section. That was the step 3. Okay, who can help us with the first and second step? Because step 3 is obviously here. All right, but who can help us with the first step and then the second step? Just a quick record of what we have done. Okay, please the name, but this time around, please pronounce the name so I'll be able to pronounce it next time. Please, you can speak.
The first step is to analyze the problem.
And please, can you add your name for me so I can be able to pronounce it?
My name.
Yes, please.
My name is Kayum.
Kayum.
Yeah.
Okay, I guessed it right then. Okay, so Kayum, thank you very
The,
much. So the first step is analyzing, right? Okay, I'm sure we all do agree. Then the second one is
the second one is plan. Plan the algorithm.
okay. So the second approach to solving a problem is planning. After you have analyzed, then you have to plan. The third is that you are going to write an algorithm. All right, you are going to write a pseudo code. If Vida is here, she'll be very proud of me. You are going to write a pseudo code, and then you are going to desk check your algorithms and then your flowchart. You just desk check everything, put everything to the try, whether the code or whatever, put everything to a try. Okay. So as I stated, we desk check an algorithm and then we desk check a program as well. Okay. So remember, algorithms and the program are two different things altogether. Even though algorithms assist you upon how to build a program, algorithm is a different concept. All right. To it's like giving the program to somebody who will just read and then try to understand. But when you give the actual code to someone who does not understand the programming language, that one the person won't get anything that you are writing. But when you write an algorithm, it's like you are giving the person a set of instructions. Remember, it starts with a verb, and if you do recall and you engage yourself in the quizzes given to us, you realize that one of the questions stated that algorithms start with a verb, right? So I think in our last section too, I made mention of that they start with verbs. Okay, so let's not forget that. All right, they give an instruction, and you know what? Verbs call for an action. Okay, so sit, stand, do this, jump, whatever. So that is that. Okay, let's not waste time on it. Okay, so as I said, after step 3, programmers has an algorithm. All right, we have an algorithm by now, and then we have just checked it, or we have placed it to the algorithm to a text. All right, to see whether the expected outcomes are going to be produced. All right. Now the first step in the process is coding the algorithm into a program. So this is where everything gets dicey. If you don't really pay rapt attention, you won't follow what we are doing. Okay. So please let your mind be here. Okay. So we are in the fourth step. Okay. And this time around, we are going to code the algorithm into a program. So this is where the coding starts. Okay. Let's not forget that. The step begins by assigning a descriptive name, a data type, and an optional initial value to a unique input or a processing, that's the IPO chart. Okay, they are used to store these things these containers that we're about to create here, or these storage spaces, and the name and things. I don't want to really talk much about it because I will show you. All right, they are used to store items in the computer's internal memory. All right, so we will look at that. So a computer's internal memory is composed of memory location Okay, I've mentioned it again. Okay, each with a unique numerical address. A unique numerical address. That's a computer's internal memory. Similar to the similar to collection of storage bins. All right. So just like that, right? Like storage bins. You know that when you go to a well-organized organization, all right, they don't normally put everything. And so even though they are all wastage, they don't actually assign all of them to the same storage bin. All right, papers go somewhere, plastics go somewhere, bottles go somewhere, liquid flows through somewhere. All right, they're always though not wanted, but they have a particular different way of being disposed. Okay, some are meant to be recycled and all metallic stuff goes somewhere and all. We don't really mix them together. Okay, and even if you mix them together, at a certain point they'll go and separate them. You get it? So let's appreciate that as well. So even though memory is a memory, all right, we have different memory locations. Let me be specific. All right, memory locations in a memory. All right, we just create these different memory locations to assign different things to them and call upon them as of when they are being wanted or needed. All right, so that's that. So each address can store one item at a time. You realize that each address can store one item at a time. All right. Address can contain number, text, or program instructions. Number, text, or program instruction. I don't know why there is no symbol here. All right. In other words, I would have just edited this side and said addresses can contain characters or program instructions. All right. That when I get to the code aspect, you understand why I will like that symbols will be added here. All right. Even though um uh addresses may not specifically be containing symbols. Why would I just be putting a symbol in an address? What would I be using a symbol for? But I can do that for something, and I'll show you. Okay, so it's not mostly used, but it's not wrong as well. Okay, so just put that behind your head. Now, to use a memory location, programmers must reserve the address. All right, to use a memory location, programmers must reserve the address. The process of reserving an address or reserving a particular memory location, all right, is called declaring. So when we are declaring a memory location, in programming, what we are saying is that we are first creating the memory location, giving it a name. All right, we are first creating a memory location, giving it a name, and then reserving it for whether we want to store something there now or store something there later. Please, do we understand? Please, do we follow? Do we follow? Or is there any question? Okay, Rachel, thank you. Let's proceed then. Let's proceed. Okay, so now declaring memory location is done with an instruction that assigns a name, data type, and optional initial value. We need to do these things to be able to these three things, but mostly two. Three, the third one is optional, okay, as is obviously written here. All right. But if they ask you what are the three things required, all right, in as of when you are declaring a memory location, all right, even though it's optional because they are looking for three things, please find it and put it there. Okay, that is giving the memory location an initial value. Would it be better for? From kind would it be better for the meantime? All right, and remember, even an empty box is not empty. The space inside the box is something. Okay, so don't forget that the space inside the box contains something. So an empty box is not really empty. Okay, unless you want to argue with me, I will admit to the fact that it is empty. But if you don't want to argue with me, accept my contribution. Let's continue. Okay, so the name allows the programmer to refer to the memory location elsewhere in the program using a descriptive word rather than a numeric address. So why do we do this creating of naming memory locations and giving it a name. All right, we do this. It might be asked. All right, so that it may be called upon. All right, you may need to call upon it some other time in your code. Okay, so it allows the programmer to refer. That's the same as the calling upon, to that memory location. All right, elsewhere in your code. Okay. But how will you call upon somebody if you don't actually know the name? So that's why it's very, very important to give the memory location a name. Okay. If all of them, their names is memory location, you call upon memory location, which one should the computer pick? Right? You have to give each and every one of them a particular specific name. All right. You imagine you go onto my desktop and then I ask you to go and find a particular folder. All right. And then there is something inside that folder I need you to try and put on a pen drive and bring to me. And then you ask me, what is the name given to that folder? You definitely ask me that question, unless you don't know what a folder is in the first place, and you are just, or maybe you assume that that's the only folder on the screen. But if you go there and realize that you find a whole lot of folders on my screen, all right, and you didn't ask me that question, you will come back and ask me. I went and met whole lot or a bunch of folders on your screen. So I would like to know the name of the folder you want me to pick the information from. All right. So this is the same as what I'm saying. Okay. Without a name, it is very easy. It's very, very difficult for you to identify something or call upon something. Please, I'm sure by now we all agree with that. Okay. Now the data type indicates that what type of information the address will store. Remember when I was giving this example of boxes, all right, I stated the fact that I gave you money to put in these boxes, okay, and then you can agree with me that the only thing you are going to be putting in the boxes is money, all right, because I said that the boxes have been made to receive your money. Okay, so that's what I'm talking about. So when this whole thing is trying to say is that, all right, when you create a particular container, give it a name. All right, there's a purpose for creating a container in the first place, and so you describe the container. You let people know that this container is meant for keeping metallic stuff, plastic stuff, so that nobody goes there, even though the container has a name. Okay, even you just give it a simple kind of description. What type of bin is this? The type of being it is will let me know. And we all agree as humans, you know that the type of human being will let you know how you relate with that human being. Because I don't want to use this word here, okay, but I can speak to you in a very jovial manner, but to somebody standing somewhere, the person might see it as an insult, just because of the type of individual we are talking about. All right. So when you tell me that this container is meant for keeping this type of stuff, all right, I don't go and put any other thing else but that particular type of stuff inside there. Otherwise, I'm insulting the container. In other words, that's what I'm trying to say. Okay. So I can look at you. Let me use Prince Darko for an example. Right. I can go to Prince Darko and have some kind of conversation, some kind of chat, right? I can even call him at some certain times, all right? But I'm not sure I can call I don't, but it's Hazel, right? I'm not sure I can call maybe this name is very dicey. I have two ways of pronouncing this name, either Sophia or Sophia. But please bear with me if I'm not able to pronounce it well, okay? So I'm not sure I can just call her maybe at 1 o'clock at dawn and I'm expecting her to answer because of the type of human being she is. Okay. To me, personally, I mean what I'm trying to say that my relationship with her, all right, and as far as it stands, we are just mates. I can't call her that hour. But maybe I can call Prince who to we are just mates at that hour and Prince will answer. We can even chat. Talk about necessary things and sometimes even necessary ones. Okay, all throughout maybe the entire night or whatever. Okay, but I can't do that with Sophia or Sophia because of my type of relationship I built with her. Okay, so looking at the type of relationship or the type of individual, you know how to throw your words to that individual. You know what to store in the memory of that individual. Okay, you can't walk to your pastor and say, "Hey, Jimmy," you know, but you can walk to a friend and say, "Hey, Jimmy," you know. Catch your pastor say, "Hey, Jimmy," now you guys, you know how the end result will be. You will be doing fasting and prayers. Okay, bear fasting and prayers for some time because okay, but I hope you can really relate. Okay, so looking at the creating a container, giving it a name does not actually tell me what I should put in a container. It is the type of container you have created that will let me know that this container is meant to receive this particular thing. Okay, so it's very, very important. We take note of that. Do you have any questions so far? Or so far so good? So far so good. Right, I'm really running with time. So far so good. Just a thumbs up so we move on. Okay. Reaction, no, it's very, very important too. I need them. So okay, thank you, Emmanuel. Joshua, okay, thank you.
Yeah, yeah, I just joined.
Oh, okay, and you are really behind. Sorry,
Yeah, I was sleeping.
Ever. All right, let's continue. So there are two types of memory locations to be declared, and we have stated this from the beginning that the two types of memory locations we are going to declare, right, is a constant and then a variable. Okay, so let's look at variable. What is a variable? We have explained it in so many ways before even the lecture actually began. Right, we went with the slide. What I mean by actually began, we went into the slides. We used our own words and kind of different understandings to try and explain what a constant and a variable is. So I will not really waste much time on it. Okay, so variables are memory locations whose values can change during runtime. All right, not after runtime, during, and sometimes before. Okay, but not after you have actually run the whole thing. Then is when its value is going to change. When it is running, maybe initially you give it 2, and later on that same container you assigned a 5 to it, so it is running with it. All right, it worked with a 2 initially, whereas that when it got to a certain point its value changed to a 5, so it's from that 5 onwards it's going to work with that memory location as having 5 stored instead of 2. Okay, so that's what I'm just trying to say. That's what I mean by runtime. Okay, when the program is running, most memory locations are variables. Most because the a cutlery set. Things can happen. Okay, if you don't want any trouble, please try and make most of your memory locations variables because you don't know what may happen. All right, people change. All right, people make mistakes in their inputs and everything. So you know how we all agree to the fact that when we make something too rigid, it does not really rotate. Okay, but when we make it too flexible, rotation is very, very simple. Okay, I mean what I mean by rotation is regulating with it. Okay, it's very, very simple. But when you make it too rigid, all right, it becomes very difficult to operate with. And we all like a flexible environment. So please, whatever you are storing inside your storage memory locations also like a flexible environment, so please create a flexible environment for them. Okay, I'm just pleading on behalf of your um, data to be stored. Okay, please make the environment quite flexible. Please hold on for me. All right, let's proceed. Sorry for that. He might go back again, so let's continue. When he does, I will plead with you that I will have to attend to him again. All right, so most memory locations are variables. We have already said that. Named constant moment. All right, let's move. Sorry, my apologies. Let's move. Okay, so let's look at the. This one is like what I stated earlier. Okay, like with the whole concept of 200 CD and all. So we have a particular box. Okay, you can let's look at the three things going on here. You have a particular box. Okay, and then we can obviously see that these boxes are empty. That means that the initial value given to these boxes is nothing. Please do we let's break this picture down. All right, because when we understand this picture, it's not, it looks like a just normal cartoon picture, but it has so many explanation behind it. So let's try and then break it down, and then when we understand this picture, I know that we are okay. Okay, then we can move to the coding environment and do things there because we are working with time. Okay, and I know that when it gets to the coding environment, that's when the questions will actually start coming in. People start throwing questions at me. So I want us to really get there. For now, we are quiet because it's like we are just reading. All right. So now we can see. Let's look at the sandals here. All right, and then its container. We can see certain things from here. We can see that a container is there. All right, a space to store this sandals is there. We agree to that. We can also say that it has been given a specific name for us to know that this is what we are supposed to put inside the container. We agree to that. All right. And we can also see that the size of this container allows that what will fit inside it is this sandals. This thing can go inside it. You might try to squeeze it inside, but it won't go. The boots obviously can't also go inside it. All right. Then we can also see that this container has nothing inside. It's empty for now, unless you decide to pick this and then put it inside. So I hope we really understand that, or you have any question to ask about that, you can ask about the picture. Let me go back to it, and if you have any question, you can ask, or we should just move on. If I move on to thumbs up, so we move on. Okay, thank you for the reaction. Let's move on then. Okay, so a memory location has a 0.0005. We all know that this is 0.005, right? 0.00 means that 0 point something something, and then it has this also, which is also another data type. Also has this one which is a data type, and this one is a data type. All right, let's try and then understand this here. I'll come back to this particular part of the picture when we are I will come back. It is at page 7, so I'll come back and I'll ask some questions here. So don't we are not going to ignore it. We are going to come back to it. So put down in your head. So selecting a name for a memory location. What are the things we have to do when you are selecting a name for a memory location? Now a name, or we know when someone, why do we give people a name, or what is name? Names is something that help us to identify. So names are sent in coding, is also known as identifiers. Okay, so names are assigned to a memory location. All right, so that what does it do? It gives it a description. Okay, so that when we see it, we know we are able to relate to a certain extent to what the container is meant for, or the storage location is meant for. Okay, so it kind of like describes like an adjective over here. Okay, then should also help the programmer or other programmers, all right, remember or understand the memory location's purpose. So when you come to me and then I've named a memory location sandals, okay, you should try and understand that what is meant to be kept inside that memory location is sandals, okay, because of the kind of name I'm giving to it. All right, as I said, it describes it to a certain extent. Okay, then should be as short as possible while still being very, very descriptive. It should be as short as possible and control a whole passage for the name of a variable. I know what people can do. As I stated earlier, people are cutlery set. So please, and please again, no matter, even don't hold me by the fact that because I'm saying that it should be very descriptive, now control a whole passage, a whole paragraph as a name of a variable or a constant, but that one is not allowed. I know that some people will say that, but it should be descriptive. I didn't say write a descriptive essay, please. Okay, so that one too is there. Make it as short as possible, as you can. Okay. Then let's continue. Now, short names are easier to read and result in more concise code. It does not make your code too so much. It does not make it too plenty, right? So try and maintain a short name, but the name should be very, very descriptive. It should hold some kind of not it shouldn't be void in terms of understanding it. It should not be ambiguous. It should also have different kind of meaning when somebody looks at it. Okay, it should not be like that. Okay, so that's what I'm trying to say. All right, so now let's look at the rules that are used in C++ for giving names to a variable, a memory location. The reason I keep on saying variables because I'm not specifying on constant. Because what makes constant really different from variables is just some few things, okay? But our problems will be based on variables because they change. All right, constants remain the same. So if you understand the whole concept of variables, we just have to understand the fact that it won't change, then it becomes a constant. Are you okay? So that's why I keep on saying, referring to memory locations as variables, but not constants, because for the purpose of this lesson we're focusing more on variables. Okay, constants actually have nothing too much different from being a variable except from the fact that they don't change. Okay, so the same rules you can use in naming a variable, you can use that same rules in naming a constant, just that you have to tell me that it's a constant. That's all. Are we okay? So let's look at the rules. So name must begin with a letter. Name must begin. Please, you can write it down because I'll use it against you. Name must begin with a letter. Okay? And contain only letters. Are you following? Numbers and the underscore characters. Or underscore character. Let me put it that way. It's a character. Okay, so let me take it again. Name must begin with a letter and contain. They said must begin with a letter and contain, not begin with a number, begin with an underscore. It says it must contain it. That is if you want to put it there. Okay. Next thing is that no punctuation marks, spaces, or other special, I call them reserved characters, okay, or symbols like the $sign and the percentage sign. Okay, in the name, we don't entertain that in the names, okay, because they are special characters. They are meant for special purposes in a coding environment. Okay, then cannot be a keyword. There are certain words that are keywords in C++, and when we start coding, you start to see those keywords. When you type them in my coding environment, when I type it, it changes color to blue. By trying to tell me that it's a reserved word. The other name for it are reserved words. They are reserved for some purposes. Okay, you can't use that as a name. Are we okay? Then names are case sensitive. This one is not really a rule, but it's like a caution. Okay, so names are case sensitive. It means that when I declare a container and then I give it a name like this, and later on I call upon it like this or like this, it's not going to work. It's going to tell me that I didn't declare any container or any space this or this. Why? Because even though it is the same word discount, the casing, what I mean by the casing is whether the uppercase and stuff is very, very important when you are typing the name of something. Okay, so when you write it in this case, make sure whenever you are calling upon it, you type it exactly like this. If you type it like this or like this, it will not give you what you are looking for. Okay, so that is that. Okay, then we are selecting a name for a memory location. Let's continue. All right, now let's come to, I think, okay, most programmers use, remember they said most programmers use uppercase letters for named constants and lowercase for variables. What this is trying to say is that even though it is mostly used, that is why it's becoming like a norm, but it's not a rule that constant must all be typed, the names of constant must be typed in capital letters alone, right? just for easy identification of what a constant and a variable is in your code, the name we give to them, we try to vary them by typing the constants in all caps and then variables in a different way. Are we okay? So just put that one. But that does not mean that if I should declare a constant and I should type it like this, the name for it like this, it is wrong. It is not wrong. Okay, just that it is mostly done, so it's like becoming a norm. And we all agree to that for that something that is mostly accepted, all right, becomes something like a rule. Okay, so that is that. Now, if constants contain more than one word, we separate them with what something called an underscore. This one here, all right. You can see the underscore here. This is it. Oh, why is it highlighting my? You get what I'm trying to say? Okay, that's the space, that symbol between the X here and then the R here. That's the underscore. Okay, so if it contains, and the same thing for variables. Okay, if the variable name you are giving to the thing contains more than just a word, we separate these two words with what? An underscore. In case you don't want to do that, then there is something done called camel casing. All right, I think in our quizzes to this, a question came on camel case. Okay, all right. So if variables contain more than one word, all right, we capitalize the first letter of each word after the first. Okay, so what it's just trying to say is that, all right, you type the first word, all right, type the first word using a small letter like this. Okay, and then after this first word, any other word that follows assumes a capital initial letter like that. So that it makes it quite easy to separate the reading of it, all right? And I'll do an example of that too in the coding environment for you to see why it makes it read. We can know that this is adjusted gross income. How am I able to read it so smoothly? Because of the kind of um, differences that was created in the word using these capital letters. If everything was typed in small letters, trust me, you pronounce a different word. Okay, so that is that. So um I will not, I don't want to ask questions here. I don't want to ask questions, and then this thing I will not, I don't want to talk about because the answers are already. I want to challenge you. So I have 2 minutes to do something here before I move you to the coding environment. I want to challenge you. So I will not really talk about what you are saying here, right? But I will challenge you on this same thing in the coding environment. I'll be asking you questions. Why these things are invalid names? Because right now the reasons are here. You can see it clearly. You be sour, you just read it for me. So it's not going to be really that productive for me in the sense of on my end trying to know that you understand. Okay, not that it's not productive. What is here is not productive, but on the sense of me trying to know that you understand. Okay, so this is like something that we also be working with also equally in the coding environment. I don't want to waste time on it because we visited the um, IPO chat variable names. Okay, so we know in an IPO chat we can write however we actually want to write. Okay, but when it comes to the coding environment, when you're giving that name, there's a particular way to do it. Okay, we will look at all that. Um, Selecting a data type for a memory location. Memory location come in different types and sizes. Type and size you choose depend on the item you want to store. As I stated earlier, the type and size from the containers picture that we saw over there, we saw a sandal, we saw, I think, what is this, sneakers, then we saw a boots. Okay, so the type of item and then its size will determine the type of memory location you are going to create for it to store it. Okay, and the memory location will only accept an item that matches its type. I also stated from the picture that we will try to push the boot into the container of the sneakers. We will try, but it will not be possible because of its size. Okay, and then because of what it is meant for. Okay, so that is that. So I'll take it again. A memory location will only accept an item that matches its data type. Data type of a memory location is determined by the programmer when declaring the location. Let's go back a little bit before we move. This is the only backing I'll be going to ask a question. When we say we are declaring something like a memory location, what are we talking about? I stated that. So let's not, don't let me down. Who is going to answer that for me? When I say we are declaring a memory location, there are three things that goes in declaring a memory location. The third one being option. I'm just giving you a hint. So when I say I'm declaring a memory location, what am I saying? Okay, today my guy is on fire. Let's go.
Like I think what I understand is you are calling someone or you are calling something.
Declaring. Yeah, that word is it varies from calling. All right, calling upon it. Yes, I decree and declare.
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 You are revealing something.
Okay, 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 okay. All right. And then any other? Yeah, I'll mention names. Emmanuel has admitted. Thank you, Emmanuel. Let's go. Emmanuel. Okay, let's proceed then.
Initial value.
He said,
Initial value.
no. Okay, no. Let's proceed. All right. So when I say I'm declaring a memory location, it means the first thing is that I'm creating a memory. In other words, it means I'm creating a memory location. And what goes into creating a memory location? You have to tell me what type of data is going to be stored there. Okay, that's what I mean by data type. You're going to give the memory location a name so that it can be easy to identify. Remember, names are known as identifiers. You better choose to assign to it optionally an initial value if you want. Are you okay? So that's what we mean by declaring a memory location. I've stated this. I will ask you a question about it, so please do not forget. Data types. All right. I will not talk about it. I'm going straight into the coding environment to do that. All right. But know that data types is like the various ways data can exist in. All right. Remember, data is a raw or unprocessed word fact. So the various way data can exist in is what we call as data types. All right. What I say, the stages of matter. All right. The various ways in matter can exist in, whether solid, liquid, or gas. All right. That's what I'm just trying to say. Something like that. Okay. So just one data can exist in so many ways, depending on how you play around with it. Okay. So that's what I'm trying to say. So let's open our Dev C++ environment, and then there are certain things I've not talked about here, but I will talk about them in the coding environment. So please, let's dive straight into it. Let's dive straight into it. I'm sure by now, since I've said let's open, those with very fast machines have already opened it. So mine is now opening. There's a folder I've created. Let me just go and then open that folder rather. There's a folder I've created for this lesson specifically on my desktop. So C++. Okay, let's go. So today, I can't believe all these things was not in the slide, but I will have to teach it. I hope time favors us. Okay. Now we are going to talk. We can't code without first writing these things. I don't know if there's the next section will really go into letting us know what library and is what using namespace st, but so far I've read it and I've not seen it. Okay, so I will talk about it, but briefly. Now next session I'll spend more time on it. Okay, so pardon me if you don't really, but for now we have just been following our lecturer, but for me I actually know what they mean, so I will talk about them. But for now, just like we have been following the lecture, just follow me for just the purpose of learning variables and constants. Just follow me so I will focus on that one rather. I'll come back to explain this thing later. Okay. So just type exactly what I'm typing. exactly what I'm typing here. Okay. What would I be working with again? So so far so good. I think this is the one that so far we have learned about, but I know more libraries. Okay, so I will just play around with some of them. Just play with some of them. It's fine.
Yo, Freeman.
Let's
Please, the line 3, the CMA, what does it mean?
okay, so the reason why I'm saying I will not really spend time on them is because I will actually dedicate a different section for doing that. Okay, I just want us to really know how to name variables and why the rules are there and all. So, but for now,
Oh, okay, okay, okay.
just follow. But I will talk about these things later. Okay, I will talk about them. It's a promise.
I said, please, can you change your background, like, because I can
You
hardly
can
see you.
see.
I think I'm having an eyes problem or something. Or it's okay. It's okay.
Only,
It's okay.
Will
only
this thing
cancel.
help?
Hello,
Will this thing
sir.
help? Will this help? I've
Yeah,
enlarged.
Please,
Okay.
please, are you using a desktop computer?
me.
Yes.
Please,
I'm
please,
using my phone. I'm using my phone for the thing, but I have PC. I have PC.
okay, I get it, That's why
Because
the fonts
if I'm using the
now
PC at the same time, maybe
it will distort. I
yeah,
get you.
mm.
So, but I hope that I've enlarged. I hope it's better now.
Yeah, it's better now. I can see clearly.
Alright. Let's just type for now. Let's just type what we are saying. Oh, sorry. Let's just type what we are saying and then let's follow. Okay. So inside this space is what I will be doing my coding. Inside this space here, that's what I'll be doing my coding. Okay. So we have talked about variables and data types and how to declare a variable how to declare memory location specifically speaking. All right, so let's create memory locations in the computer. All right, so that we can store things there either now or later. Okay, now the rule says that in declaring a memory location we have to tell us the data type first. In this coding environment, that's what they are saying. You have to state the data type first, and I'm saying data type is the various ways in which data can exist in. Okay, so we are going to talk about quickly spend time to talk about the various data types. We have for numbers, we have a data type called float, double. Are we following? And then integer, also in the coding environment written as int. This one is not I'm just trying to give you the full name, all right? But this is how it is written in the coding environment. Okay, int, short as int. I just want to let you know that this int stands for integer. So now I can clear it. Okay, then let's focus on what it actually is. All right, so this for numbers, these are the three available data types. All right, I mean numbers in coding can exist in these three forms. Let's explain them. All right, float means that a number that is having is an integer. No, I want to say it's an integer, but it's a number. Let me just go general and say a number that has a decimal um, value attached to it. Okay, so a whole number with a decimal value part is called a float. The same thing goes for a double. The difference between the two of them is that floats store less sized let me say in terms of size is able to store lesser numbers compared to doubles are able to store big decimal values. Okay, so it's the same thing, all right, but to be on the safer side, I'll always advise you that whenever you are declaring your data type, use double because you might end up storing a decimal value that is big, and you don't want the computer to automatically cut it short at a certain point. So the best thing to do is that when you're declaring your data type for decimal numbers, use double instead of float. Please, do we all understand that? Or somebody has a question? Okay, no hands means that we understand. Let's proceed then. So for integer, an integer is a positive or negative whole number. It means it has no decimal point in the number. So what I'm trying to say that when you declare a data type int or integer, please do not add decimal point to the value you assign to it. That is part of the rules. Make sure that whatever container you create, you put what must be placed inside there. Respect the container and what must be put inside there, please. Okay. So for float, we are allowed. I want something that is float, maybe something that has a decimal, something attached to it. I just want to somebody give me a name of something that will have a decimal attached to it. A name of something that will have a decimal attached to it. Can you tell me a name of something that has a decimal attached to it? Tell you about. Okay, Monica.
Average score.
Okay, average score. Definitely, average means that some kind of division was done there. There's a tendency that the return will be a decimal value. So let's take average score. Now, who can I'm about to type something here. Okay, we are learning two things at a go. You can tell me what if you can tell me if this name I've given to my container, all right, meant to store a data type as float is wrong. Who can tell me why there is something wrong with what we are seeing over here? The name. There's something wrong with the name, obviously, but who can tell me what is wrong and how we can correct it? I think I saw a hand up. Yes, my friend. Unmute and speak.
There's two ways that you can write. You can write it using the underscore or the camel case.
So can you help us by telling us what is wrong with this code and how we should this name, all right, and then how we should go.
The space that you are given in there. So it's supposed to be underscore or.
So you're trying to tell me that I should clear this space, right? In the name, I clear this.
Clear that.
So all right. So
Yes.
I clear it. Cleared
Or you
it. All
can
right.
or you can put underscore there.
I can put an underscore here and it's allowed just for readability to separate the two words. Please, we
Yes.
all agree to that.
Or you can the camel case, which is the score. The first letter will be capital. The score. The S will be capital.
So is this correct?
Yeah, I think yeah.
There's still something wrong here. You can tell us. You can tell us. It's not really a violation of a too much rule, but for the sake of professionalism, there is something wrong here. You can tell us.
Yeah, unequal to sign.
Sure, boy.
The termination you didn't terminate it.
Boy. Sorry. Yes, please. Let's look at it again. You can tell me what is wrong with the name for the sake of professionalism. All right. I said the name, or not any other thing. I'm talking about the name. What is wrong with it? Take a close look at it. Definitely, it's not the spelling. I've not spelled it wrong, so don't let your mind go there. But take a look at it. No responses. Hey, okay, your class I can make go. Yes. Oh, is it my friend? My friend. Yes. You guys, you still have something to say.
It's the first Hannah.
Is there?
That's the first one. I didn't raise my hand again.
Oh, okay. Hey, people, help me here. Let's talk. What is wrong with this name? So it might look just fine because it has obeyed most of the rules of naming a variable. For now, we are naming variables, okay? But there's still something wrong here for the sake of professionalism, and that is all. Okay, Monica, carry us go.
The average score, the A is capital. Are we supposed to be small letter
The
O?
A is capital. Yes, don't ask me. Otherwise you say that I was the one who said it. It is supposed to be capital as well. So
Supposed to be small letter.
okay, all right. Let's clap. I was about to say let's clap for her, but she has said it. That's true. Okay, that is it. All right. According to the professionalism aspect of it, and it's in the slide. It is in the slide. I can go back to it in case you might be trying to bring yourself up. All right. It is in the slide. Okay. I can go back to it so that you have an appreciation of it from the slide. And I'm the one just saying it. Which part? Okay, here is it. They said that name must begin with a letter contain. Okay, no, it's not here. It's naming. I think it was a naming variables. Naming variables. It was there. Small letter. Short name. Blah. Names are case and no. Must begin with a letter, a number. No. It's in the slide. I'm just finding it difficult to find it. Okay. Capital. Good. They said capitalize. Here is it. All right. Let's read it together so we can say we can capitalize. Let's say capitalize the first letter of each word after the first. After the first. So this is the first word. After it, we capitalize the first letter of each word. So after the first, that's when the capitalization happens. This is when we are naming variables containing more than just what a word. Okay, so that is that. Please, do we understand it? A thumbs up, please, if you do. If you have a question to
Come again.
I should come again. Okay, Joshua. What I'm saying is that when we are naming a variable or giving a name to a variable and it contains more than a word, the first word, all right, is spelled normally without any capitalization involved. All right. Then after the first word, then we capitalize the first letter of each word that follows after it. Please, do you understand it now? That's what I was saying. For the sake of
Yeah, I get it.
professionalism, there was something still wrong with the name we have given to the variable. Okay, so this is it. This is what it's supposed to be. So now we have obeyed two of the things involved in declaring a memory location, specifically a variable, because we are doing variables now. We gave the data type, what type of data is going to be stored inside there. We gave it a name for easy identification, and then what is left. That one is the optional part of it, but let's try and appreciate it here. What is left? Okay, Joshua.
Okay, so what if maybe you've forgotten and you did it capital? It is still wrong.
It's not wrong. Obviously, it's not wrong, but just for the sake of professionalism. Okay. That's why I stated the fact that some of them are no rules, even though they are stated as rules, they are not really rules, okay, but they are just there to prevent future kind of problems you may have, okay, but they are not rules. They are just there to prevent some kind of. They just make your code more professional and readable, okay. Yes, you can ask your question. Kai, Kayum.
I just want to try to.
Okay, yes, try. Trying is good.
Yeah, you assign it to the initial value, which is optional.
Okay, it's very true. It's correct. All right, so we can choose to assign an initial value, and we use the equal to their. There are. I'll also use this opportunity to explain what we mean by assigning. All right, there are some symbols that are used to assign values to a memory location. The first one is equal to, obviously. All right, it means that whatever is going to be at the at the right hand side is going to be given to whatever is at the left hand side. All right, equal to. Why? Because they must be the same. So they're trying to say that whenever you see average score, it is the same as what has been given here. Are we okay? At the right hand side. And then the other one is less than or equal to. No. Wait. Assignment operators. Hold on, let me just get it up here. I have them in a document for us. Operators. Uh, Practice student notes. No. Um, no. Okay, I think it's this one. Good. Good. So we have comparison and assignment operators. So assignment operators, these are them. Okay, let me enlarge them for you to see it better. So these are the assignment operators. We have the equal to. All right, it assigns the value of 5 to x. So wherever you see x, we know that x is 5. Are we okay? Then this one is the plus equal to. All right, this adds 3 to the. I come to do a little bit of, let me say, a drill here. Okay, so now we are saying that the initial value, because it's a variable, we assume that everything on this table here is a variable. So let's do a little bit of math here. I can put a calculator to it if you want. I first named a variable as x, and obviously we can see that it is an integer. Okay, it's a whole number. And then later on, I say that x should be this. What it's trying to say is that I'm supposed to take 3, add it to the initial value of x, and then assign it back to x. So what is the new value of x now? If the initial value of x was 5, I've taken that initial value of x, and then the rule said that whenever you see plus equal to, it means we add 3 to the x. So I took 3, added it to the initial value of x, all right, and then assigned it back using the equal to. So the plus here means that add the 3, and then the equal to means that whatever you get, assign it back to x. So what is the new value of x now?
I think it will be 8.
It will be 8. Very
Yes.
good. Anybody here who does not understand? Monica, your hand is up. Do you have any question? Okay, that's gone down real quick. Wow. Okay, so it's true. It's true. Okay, let's go on. Now I'm trying to say that I'm going to subtract 2 from x. So what this one means that these are assignment operators. Don't forget. It means that subtract 2 from the new value of x and then assign the result back to x. So what will be the new value of x now?
6.
6. Very good. So I think at this point we are getting it. All right. What this one is trying to say is that we are going to take 4, multiply it by the new value of x, and then assign the new value back to x. So what will be the new value of x now?
I think it will be 24. Oh.
6 times 4 is, very good. So we are done. So and then there is this one too. Okay, this one means it's the same logic. All right, pick x, the old value of x, divided by 2, and then the new value, assign it back to x. Okay, so that's the whole logic behind this. Please, do you all appreciate the assignment operators now?
Yes.
Okay. So it's not only equal to. So when we talk about assigning, let's not our mind only be focused on equal to. Okay, it's no. So I can, whenever you see me use these things, don't be like, what kind of alien things are going on in the code. You should know them because we have talked about them. Okay, so but for now we are using equal to. So we are saying I'm assigning an initial value to it. All right, but the initial value are assigned to. Remember, we stated from the rule that even though this is optional, when you choose to do it, you have to follow the rules. Are you okay? And the rule says that you have to look at the data type before you know what you are assigned to it, because we are putting the respective item in its respective container. Are you okay? So we are looking at it to be a float, and a float must have a decimal value. All right, decimal part of it. So starting from 0.0 to point whatever or 0.9, all right, is a decimal interval. Okay, when it exceeds 0.9, then it's known as a carry on as +1. So let's just as we are doing in the binary the decimal number system. Okay, not in the binary, but the decimal number system. That's what I'm talking about. So we can have a 9.5, right? Then I terminate my every line of code when I'm done. Okay, 9.5, I terminate it. Remember, this thing is known as terminating. All right, it means you have ended that particular line of code. So whenever it's being read, this is the only thing that is going to be considered to be on line 7. Okay, line 7, because you have terminated it. Are you okay? Then it moves to line 8 to. Now, if I do this, Control C, then let me do a Control V here. Please, am I wrong for double? I've assigned the same thing to double. Am I wrong? I've
No,
assigned
sir.
the same value to the data type double. Am I wrong?
No.
No, yes, because doubles and floats deal with what? Decimal values. But the only difference between them is that float is not able to store larger decimal values. The computer will by default cut it at a certain point. Okay, but for doubles, it's able to store larger decimal values. Are we okay? So for being
Okay.
safe, okay.
Mr. Felix.
Yes, please.
So what if you refuse to bring the float, then you bring only the double? Would it run and give you a correct result?
Yes, as I stated earlier, the type of container, the container is the container. All right.
Okay.
Nothing. I
Okay.
said this from the beginning of the container is the container. But what you choose to do with the container is what matters. Okay. And when you choose to do something with the container, you have to follow the rules set by the
Okay.
container because it won't change. Are you okay?
Okay.
So as I'm saying,
Thank you.
to be on a safer side, it's always appropriate, and the best practice to do is always when you are dealing with containers meant to store decimal numbers, declare the data type as double. Are we okay? Try as much as possible to avoid float. All right, unless you know that whatever program you are running is going to deal with decimal values that are not too big. Okay, but if you know that the tendency of it input either by the user or you yourself is going to be a big decimal value, try and then stick to the double usage. Okay, again, I will say I'm not saying the usage of float is wrong. I'm saying for the best practice is to go with double when you are talking about decimal values. The reason being is that it's able to store bigger decimal numbers. Please, do you agree? Do you agree? Okay, let's continue on reaction for that. Now, the next one I'll talk about with numbers is integer. Integer data type. Integer stores a positive or a negative whole number, not decimal number, whole number. So it's very good for declaring types of data like age. Sorry, age. Okay, age is always a particular number. We don't have somebody's age to be 2.3 years old. Do you understand? So for certain things like this, when you want to create a container to store somebody's age, which is a number, all right, a container to store somebody's age, I've given you the name age so that it will be easy for you to identify that the container, what has been stored inside the container is age. The other name for names is called identifiers. I've stated that. Okay, so it helps you to identify what container it is. The data types helps you to know what has been stored there, the nature of it. All right, that it is an integer, and then we assign to it an initial value. Okay, then we terminate it. All right, remember you can choose not to assign anything here, and if you choose not to assign anything here, there's a different way of typing this thing. The whole whatever you have placed here, and then the assignment operator must disappear because you're not assigning anything to it. So this is how it's going to look if you choose not to assign anything to it. Are we okay?
So please, I want to ask a question.
Okay, you can ask, please. Sorry.
What if you are Creating a container for a name. Let's
Hello?
say.
So we are about to go to that data type, all
Hello?
right? But
Okay.
now I just talked about numbers. Okay.
Okay.
Evening.
Now the next data type we'll be talking about, which
Hello?
will be the last thing we talk about before I start throwing questions at you,
Are you working
is
by this time? But today you people will close early.
please mute
So
mute
I'm
your
gonna
mute your
eh?
inter.
Oh, so
Let's continue. This advertisement has been better than approved by FDA. Let's continue. So the next one I'll be talking about is strings. Okay, with strings. Sorry, that's the use of words. Remember, I spoke about numbers alone because numbers can a number can actually be a word. I'll explain that to you. Yeah, let's don't attack me. So the first thing I'll talk about, the first data type I'll talk about when we are talking about letters is character, and then the coding environment is written as car. You see, when I type a reserved word for my environment, when I type a reserved word, remember reserved words, they cannot be names of either a variable or constant. They cannot be a memory location name. When I type them, they turn blue for my code them. So all these blue words you are seeing here are reserved words. Okay, remember when I type the full word character, it actually just appear there like that. But when I type the reserved form of it, so it means that I can say character, control X, and then give it the variable name character. Are we okay? Don't say it's the same. It's not the same thing. This is a reserved word. All right. This isn't. All right. We are looking at the word, not its meaning. I mean that this one means character. This one also means character. But this is the reserved form of it. But this is just a word. Okay. Are we okay? So for the I've created a memory space. I'm following the rules. All right. I've created one with a data type character telling me the nature of it. What I'm going to store inside there is just a character. So what are some of the things that is just a character? Maybe somebody's grade. Okay, either A, B, C, you had a 1, 2, 3, or 9. Or, you understand? All right, and then to assign an initial value to it, what must I do? What can I put here? The rule says that when you are using a character, first of all, what you assign to it must be placed in single quotes. I'm stating them, and I'll say it again. It must be placed in single quotes. The next thing you have to know is that what is going to be placed inside that single quote must be a letter, a number, or a symbol. I said a. My emphasis on a. It can be any of these three: a letter, a number, or a symbol. Not letters, numbers, or symbols. So whatever I choose to put inside here can only assume one form: a letter, a number, or a symbol. Are we okay? So I can just put a here. I can put AB or A plus. Are we following? That is for character. When you declare the data type character, you must respect it and assign what must be assigned inside there to it. The next way this thing can be done is to declare the data type called string. And this is the best when you are dealing with words, spaces, whatever, things that involves more than just one character. Just like we did for the double and float. Right? That strings are able to store more of characters. So it's able to store letters, numbers, symbols. Are we okay? So you can store letters, numbers, and symbols, including spaces. Please, do you understand? Including what? Spaces. But this one can just, I can even add space, or and then I just add space. Okay, so here I can only store a space as well. You can only store a space as well. So in case I don't want to assign anything to it, I can only store a space inside it. A space. Okay. All I can store is a space inside it. So that later on, whatever I assign to it will be a something. Okay, just a space. But for string, what I can store inside a string is multiple characters. Okay, so I can store multiple spaces, multiple letters, multiple numbers, multiple symbols. So the best thing to do is to not really try and use this one, but stick to the usage of strings. Okay, when you want to store letters, numbers, or symbols, or spaces, in other words, characters. Okay, characters. So you can store a and even more than a. Do you understand? Or somebody is confused. You should be confused at this point. You can store a character, a number, a symbol, or a space, or characters, numbers, symbols, or spaces. Okay, so the best thing to do, regardless of whether I want to store a character, a number, or a symbol, a number, a symbol, a letter, all right, or you want to store multiple of that, the best thing to do is that just declare your data type to be a string. Okay, just to be on the safer side. So you can talk about somebody's what name. Maybe let's take full name. What is wrong with this? Wrong with this? Okay, you can unmute and answer.
Please, but I'm confused. So,
Oh, you're confused. Ask a question.
about the string.
Okay.
So it's only words that the string accept.
No, it stores characters or a character. All right. Let me be specific. It can store a letter, a number, a symbol, or a space. It can store letters, numbers, symbols, or spaces. Please do you understand?
Yeah.
But just that the only thing that makes this one makes it different from when something is a double or an integer is created for a number is that you can't perform calculations with a number you store here. Let me repeat it. You can't perform calculations because the computer does not see this thing. Let's take and then for assigning something to a string we use the double quote. All right, remember the character I said we use a single quote, but for this one we use the double quote. So imagine if I store 23 here. It is not wrong. Somebody might arguably say that, oh, but it's a number. Why have I assigned it to a container meant for keeping? I said, don't get me wrong, I said it is used for storing character or characters, including spaces. So a character can assume a form of being a number, a letter, or a symbol, numbers, letters, or symbols. Are you okay? Or spaces as well. These are all characters. Okay. So, but the only thing about this is that even though it has stored a number, the logic behind it is that the computer does not see it as a number. You can't perform calculations with this. Please, do you understand? Unlike what has been given here, you can't perform calculations. I can calculate calling upon average space, okay, but I can't calculate with whatever name I'll give to this. Maybe I'll say age here too. I can't say that he is maybe age divided by average score years old. It won't work. It will give me an error because this thing that is not seen as a number, is seen as a string. Okay, so I can't perform calculations with it. So it's like me using 23 in a sentence. That's how it looks like. Like I am 23 years old. That 23 is not really something I'm going to perform calculations with. I really wish you could understand what I'm trying to say. Instead of actually creating a container and putting 23 there to which you can be called upon to perform calculations, when you store a number in a string, all right, or a string data type container or memory space or memory location, you can't perform calculations with that number. That's the only thing that makes it different from actually storing the number at where it's supposed to be. Yes, it will display the 23 when you call upon it, but that 23 is not seen as a number you can perform calculations with. Please do
Okay,
you
sir.
understand?
Please, I want to ask the question again.
Okay, yes.
So, if you want to enter like a phone number, are you
Mhm.
are you going to put it in the integer side or the string side?
It's best to put it for what you. That's why I said the container is a container, but what you are doing with the container is important. So my question is: are you going to perform calculations with the person's phone number?
No, you are just
Good. So because of what you want to do with it, then you should know what container you should put it in. So just for the sake of it just being a number to be displayed, all right, then I think it is very, very logical for me to put it here. Are you okay?
okay.
But if I'm going to use it for calculations at a certain point, then I think for the purpose of what I want to use it for, I will know where to store this one. Do you understand?
Yeah.
It's a very good question because and you have actually taken away one of my questions. I'm very, very annoyed at you because I was planning on asking this one. Okay, so I hope we understand that one. Some kind of reaction, thumbs up or something, so I know that you understand. Okay, let's continue then. So I will talk about the last data type then. I'll throw in some questions, or you can throw some questions at me. Then we call it a day. Okay. All right. So I've spoken about characters and strings, and I said the best practice is to use strings. Okay. Best practice, use strings. Okay. Remember what it can store: letters, numbers, symbols, a letter, a number, a symbol, or space or spaces. Are we okay? All that can go, literally everything can go into a string, but just that the question is, what are you going to use it for later on? If you are going to use it for something like calculations later on, don't store a number in a string. Are you okay? Because it can't do that. Are you okay? So that is that. Then the last one I'll talk about, all right, this has nothing to do with whether the thing is a letter or a number. This has something to do with something we call logic. All right, true or false logic, known as the logic gates or Boolean logic, or however way you call it, but just logic. All right, for now. And then that is known as our famous Boolean. In the coding environment, it is written as bool. Okay, so you see when I typed bool, it changed to blue. This is that it's a reserved word. Okay, it is a reserved word. So that is that. Now this one is actually meant for, it returns only two things: whether the statement is true or is false. Okay, and we use them for creating conditions. And that condition, if that condition is true, then whatever value has been assigned to that condition will be stored inside that container. Are you okay? So it's just that we will look at it more when we get to the if and else and if else and else and all right, we will look at it. Don't really worry yourself too much about it now. Just put it in your head that there's a data type called bool, and it's used for storing true or false outcomes. Okay, so I can say bool, and I type maybe, for instance, is male. Okay, sorry, it's male. All right, sorry. So in case, and I store nothing here, in case I ask the person to input the gender and the person says inputs male, I'll create a condition that say that if the person inputs male, all right, then it's male. This logic I've created here should return true. Do you understand what I'm trying to say? Or it should store the logic as true. But if the person inputs anything else apart from male, then that container is male should have the value inside the false. So I'll create a condition for it. When that condition is met, then something will be stored inside there. And that thing that will be stored inside there can only be true or false. Do you understand what I'm trying to say? Based on maybe your input or the user's input. Are you okay? So we create conditions for it, and when that condition is true, then true is stored there. When that condition is false, then false is stored there. Do you understand what I'm trying to say? Or there's confusion all over? Okay, so the silence means that everybody understands what I've taught today. So I will now throw questions at you if you understand what I'm saying. If you said you understand
Please
what I'm
by
saying.
please by learn with one thing, the constant. Didn't talk about it.
I said, the reason why I didn't really spend time on it because it's actually the same thing. All right. The only thing that will make a variable different from a constant that when I'm declaring it, all right, and I want it to be a constant, I will start by stating and adding this const. All right, this one. Can you see it? So now it's no longer this particular data type. Okay, its name and what has been stored inside there will not change because I have declared it to be a constant. All right. And then another rule for naming constant just for professional. Then what I've done here is wrong. It's not wrong, but the best thing to do is that for just to differ constant from variables, when you're giving it a name, type everything in what capital what letters, and then use what an underscore to separate it if it is two or more what do you call it, two or more words. So for constant, it should look something like this. When the name, okay, that does not say that what I did initially was wrong. It is not wrong, but just for professionalism's sake. Okay. So I hope I've answered your question. So declaring variables was actually the headache. All right, understanding how to but to change a variable to a constant, there are just two things you have to know. All right, you just have to put const in front of it to make it no longer a variable, and then the name you give to it, you just have to make the name differ by just changing everything to capital letters. And if it is two or more, we separate it using underscore. All right, because you can't use camel case in here. Why? Everything is in capital letters. All right, so we can't do camel case in here. So we just separate each word with underscore. Please, do you understand it? Have I answered your question?
Yes.
Okay, so I think that is that. So now my questions. My questions. My questions are coming. Okay, so I'm about to type something on the screen. At every point, each one of you have equal rights and are allowed to unmute your mic and stop me and say, "Sir, please, what you have done here, there is a mistake. This is the mistake, and this is what you are supposed to do." Please, do we all understand? So you are observing me as I'm typing. This is going to go on for just 5 minutes. You are observing me as I'm typing, and you have the right to unmute your mic and stop me at any point of what you are seeing, just to correct me because I'm deliberately going to make mistakes. Did you understand? Or we should close. Your response, please. Okay, I think your response silence means that you're not really interested. So if everybody
We're
has,
interested.
is it
I said, please, we're interested. Let's have it.
okay? For those interested, let's do this.
Sir, you made a mistake.
What is my mistake?
The H supposed to be capital letters.
Why?
Because according to the rule, it says that constant supposed to be, if you are assigning a variable or something to constant, the word supposed to be in capital letters.
Okay, so if what I'm saying is that if I'm putting your words right, what I'm saying is that what you're saying is that if I'm assigning a name or an identifier to a
Yeah.
constant, it should be typed in capital letters, right?
Yeah.
Not that it's a rule, just like for professionalism's sake, right?
Yeah, for that.
That's true. So this will do, right? This will do, right?
Yeah. I think it's
All right.
good enough.
So apart from that, there's nothing wrong with my code. I should go on. Okay, let's go on.
I think you made a mistake over here again.
Okay, let's have it.
What is my mistake?
You didn't add the int because it's you are storing integer in there, so it's supposed to be int.
So this is what I say. Right.
Yeah, and the it to I don't know. It's good, but you can write it in small letter, all in small letters.
Why? Because I'm declaring a variable, right?
Yeah,
Right.
yeah.
Okay. Okay. All right. So, but what if I still want to use this? Does that mean that I'm wrong?
No, you are not wrong, but in like to make the work nice or neat or more readable, you're supposed to write it in the small letters.
Okay. You are 50% correct. Now I am wrong from the beginning of the code to where I've gotten to, and I'm so
Yeah.
surprised. I'm so surprised that first of all, some of you have not really identified the fact that I have not declared the data type here,
Ah,
right? And then I'm trying to say that the data type constant is a constant. Okay, whatever I'm assigning as a constant, and I've called upon it again, and I've changed its value. Is that possible? Should that be done? If I can, that even be done? Because initially I've said that age, the container age, all right, should be a constant, and now I've called upon age again, and then what I'm doing is that I am changing the value of age. Please, is that possible? And if not, why?
I think it's possible.
It's possible. Why? Why is it possible?
The reason is that the first one, the constant int, it tells you that that number, that the number that you assign to like 23 will be constant. So
Yes.
if you call that number or something like that, it will be 23. But the age it can vary. It's a variable.
Okay, let me take a moment and then explain it so that you really get why I'm saying I am wrong here. I said that we are declaring two things here, constant and variables. Okay, we have thought about variables, but I said that with a constant, its value cannot change. All right. And I said that with variables, we can change it at any point in time. So that means that in case this thing here was only this part, Control C, let me just put it somewhere here. Okay, and then later on, I decided to say that let age now be this. Then I'm correct. Why? Because this thing is assuming the form of a variable. The data type, the name given to it, and what I've assigned to it can change because this is how to declare a variable. But when immediately I tell the computer that it's a constant, I can't change it. So in this sense, I am correct. Why? Because I can now say that, oh, at first I said age is 23, but now let age be 34. But when I tell the computer that age is now a constant, the container and what I'm storing inside it should be a constant, I can't tell the computer to change it anymore. Do you understand? Please, do you understand?
Yes, sir.
Are you sure? The difference between constant and variable is two things. The way we decide to write the name, all right, and then the fact that we just add cons to it. Immediately I add cons to it, it means that whatever I'm assigning here to the name age, the container with the name age on it should not and cannot change. So what I've done here is that I called upon age again and I said that age is 34, but I told the computer that it's a constant. So the understanding to the computer is that whatever I place inside here cannot change. Are we okay? And now I'm saying that change it to 34. Is it possible?
No, it's not. It's not possible.
So that means that this thing here, this entire line of code here, will return a bug as being wrong, but this one won't. Why? Because this one is a variable, and I'm saying that change it. Are you okay?
Uh-huh.
Change the initial thing I gave to age to this. So we have learned something here. All right. The last thing I want to talk about, then we go, is when you say a memory location is a constant. Please, we can't choose to leave it blank. You have to assign something there. If you say something is a constant, tell us what it is. That's the whole logic behind it. So like what I typed at first. All right, what I typed at first, I can't leave this place blank without assigning anything to it. For constant, it is mandatory that you assign something to that place. Are we okay? To the container. Are we okay? It is compulsory that you assign something there. For variables, you can leave it. All right, it's right. But for constant, you cannot do that. All right, you have to assign something here. Are we okay? So you can see that, oh, I created a constant container and I'm leaving it there for the user to, yes, the user can assign something there, but when the user assigns something there, remember that whatever the user input and is going to be stored there will be that forever. And then because constants don't really accept user input, but your input, okay, you can't, first of all, the rule says that you can't leave it blank. So I can't say that, oh, I'm leaving it blank so that the user will come and input something there. Do you understand? Secondly, too, because I can't leave it blank and I assign something here, this thing is not going to change. That means I can't tell the user to come and input something that will come and change it. Please, do you understand? So for constant, it is compulsory that when you want to keep something constant in your code, a number or something constant in your code, you are the one going to make use of constant, not for user input. Do you understand?
Okay, sir, please, I want to ask a question, but not
Say.
not really. But you see, so right now, if you are like see out in like age, which one will appear? I
Yes,
wanted to
depending.
know if you are calling
Code,
like
code, code runs in sequence from our lessons, previous lessons. So it's going to um try to see out age here. All right.
yeah,
When it
yeah.
gets, the code will tell me that there's an error because why? I said age is a constant and I've changed it. I'm trying to change it
No,
so that
I'm
we can try it
I'm
and see.
I'm not referring to that one, but like
Hmm.
if like you write const int age is equal to 23, and you
Okay.
come again and write int age is equal to 23,
Okay.
a constant and a variable or something like that. So if you are calling it
Yes, and
like
I'm saying that
you are calling
code,
age, so which one is it? A constant will appear or the age
that's what I'm explaining that code
uh,
runs in sequence. All right. I'm explaining that it will start running from the top. Okay. So when it gets here, it will not even get here because the mistake has been created here with the whole concept of me trying to change a constant or assign a new value to a constant. Are you okay? So
yeah.
when the code runs and gets here, it will stop. It will not continue to execute. It will not even get to the fact that I've made age a variable now. And even if it's able to get here, it will not accept the fact that I've given the same name to two different containers.
No, okay.
Do you understand? So that is
Yeah.
it. Yeah, I hope that is so. That's all I just wanted to talk about. And by the grace of God, I'm sure everybody understands. So if not, you can send me message, personal messages, and I'll attend to you as well. Okay. Have a wonderful evening and nice having you. I hope the session was productive for you. All right. Emmanuel.
Yes, I please want to ask a question.
Okay.
Okay, so what container are we going to use to store maybe a number that has that is raised to the power of another number? Maybe 3 raised to power 24.
3 raised to the power 24.
Yeah,
It,
is there any
it's, it,
container?
it, it is like 3 raised to the power 24. Yes, there is all based on the outcome. Okay, what we are talking about is we are performing some kind of calculations with the 3 raised to the power. You understand? So maybe I've created a container. Okay, let's make this in a variable by just removing the const. Okay, I've created a container and I've named it 23. Okay, let me clear the changed one here, and then I say that age raised to the power 24. Are you okay? Whenever I say that age raised to the power 24, or a exponent 24, right? It's going to allow that because of this library I've placed here. When I perform that calculation with age, are you okay? It's going to come back and store the new value back into age. Are you okay? That is the answer I'll get after I've raised age to the power 24. But based on what calculation I want to do, and then the kind of answer that will come out, I should know what kind of data type I should give to the container. If it's going to return a decimal number, okay, maybe square root of 24, or the square root of a prime number, definitely it's going to be a decimal answer. And I'm going to store it back inside this container. Maybe age, the square root of age. The answer, the output is going to be a decimal number. It shouldn't be coming back to be stored in an integer data type. Do you understand? So if I know that when I'm going to
Yes.
perform some calculations with age and then the answers I'll be getting is decimal number, then initially the container I should be creating for it, I should be using double. Do you understand?
Yes, sir.
But if I know that the outcomes for my calculations are going to be whole integers, then I think the int has no problem. Do you understand? As I said, the containers are the container, but what you choose to do with them is what is important. Are you okay? I hope I've answered your question.
Yes, sir.
All right, all right. Okay, since there's no other question, then let's have a wonderful evening. Thank you.